Okay, you're welcome. This is another part of our series, solving questions on set. So this question says the 90 member of a sport club play at least one of the games. It's supposed to be S. Tennis, football, and volleyball. 10 play tennis and football. 19 play football and volleyball. 29 play tennis and volleyball. N people play all the three games. 2N people play each one game. How many play football all together? So that's that. And then I want to explain certain things to us. So when we see problems like this, the word at least, so the 90 member of a sport club play at least one of the games. Now, if they say at least one of the games, let me give you an example. When we hear the word at least one of the game, that means there are people that play just one game, or there are people that play two games, and there are people that play three games. So that word, when you hear that means that there are people that you can use the word union, because the word union, if you are given a set A union B, definition of that means that the set of elements that are in A or in B or in both. So when you hear the word at least one of the games, that means there are people that play one of the games or two of the games or three of the games or all the games. So that is, I need to explain that. So let's start and put this thing in set notation format. So I'm going to start now. The first one says 90 members of a sport club play at least one of the games. So we need to put that. That would be okay. Let's put it like this. I need to let T represent those who play tennis. Let F represent those who play football. Let V represent those who play volleyball. So we have given the set their names. So the first statement that we are given is that 90 of the members of a sport club play at least one of the games. So we are given that. So what it means is that T union F union V, T union F union V is equals to 90. So we've gotten that. Then that's the first statement we are given. Then 10 play tennis and football. 10 play tennis and football. We can represent that. Tennis and football. that is 10. Then the next one we are given is that 19 play football and volleyball. 19 play football and volleyball. Football and volleyball. That is 19. 29 play tennis and football. 29 play tennis and volleyball. That's 29. N people play all the three games. Those who play all the three games, intersection F, intersection V is equals to N. Now, the last aspect is 2N people play each one game only. So I'm going to represent that. Those who play tennis only, that's what it means. Tennis only, just follow along. Tennis only, complement, intersection, and V complement is equals to 2N. So we also have those who play football only. Football, intersection, T, intersection, V. So they don't play tennis, they don't play volleyball. Is equals to 2N. Then we also have this. And those who are playing football, not tennis, they don't play tennis and they are not playing football. Is equals to 2N. These are people, that's what that statement means. 2N people each play only one game. So take note, you said 2N people each. So those who play football only are 2N. Those who play tennis only is 2N. Those who play volleyball only is 2N. So we have this. These are the statements we are given that we need to represent in set notation format. So the next thing for us is to try and sketch a Venn diagram. So let's see how the Venn diagram will look like. So I'm going to draw the Venn diagram now. I've drawn one just for the sake of time so that we will not waste much time. I'm going to copy it and paste it. So take this as our Venn diagram. So let's take this as our Venn diagram. Now we'll be putting all this statement. All those who are playing all the three games are N. So we have to put that is in this place. So that's N. Those who are playing all the three games. Now the next statement is those who are playing just one of the games. That's 2N. We've been able to get that. So 2N. I'm going to put that there too. So this place is 2N. This place is 2N. Then this place is 2N. So that's that. So it's taking shape. Then the next one, those who are just playing only two of the games. So we need to represent that. Like in this case, we have Just bear with me. I want you to see the diagram. So we have N T intersection F intersection V complement. That means they play tennis, they play football, but not volleyball. So that is 10 minus N. So that is this region. Every of this region, this place that I'm putting the cursor at the screen, theta is 10. Those who are playing all the three games is N. So you have to subtract that. That will give you 10 minus N. So we have that. So T intersection F minus T intersection F intersection V. So this is that. So those who are playing just tennis and volleyball and football and not volleyball. That is it. So that's 10 minus N. So I'm going to write 10 minus N on this side so you can see what we are doing. 10 minus N. So that is this region. So we've gotten that. So the next one is this region, those who are playing tennis and volleyball. Tennis and volleyball. Okay, let's take it like this. Those who are playing football and volleyball, we have been given that to be 19. So I'm going to do that. So we have F intersection V equals, so now they play tennis, they play volleyball and tennis and not tennis. So we put that complement. So this one will now be F intersection V minus T intersection F intersection V. So that is 19 minus N. So I want to look at it. Straight. Those who are playing this volleyball and those who are playing football and tennis and volleyball, everything here is equals to 19. So if I take this N away from this place, from this, I'll get 19 minus N. So this place is 19 minus this place is 19 minus N. So let me just put this there. So I'll have to change this to 19. So drag it a little bit. So better. So we have 19 minus N. So we've been able to do that. So now the next one is tennis and football. Those who are playing tennis and football is 29. 29 people. Now we only want those who are playing tennis and volleyball and not football. So we can get that out. So tennis and volleyball are not football. This complement is equals to So if you look at this circle, this is the place where T and V intersect. This circle. So we only need this region that I'm putting this. So when we subtract n from 29, we will get this region. So that is what we got. We got it to be 29 minus n. So now we have gotten all the data we are given. Now I want to explain something also to us again, which will take us back to the initial scene. 90 members of a a sports club play at least one of the games. So this one, it tells you all the people that were being surveyed play any of the three games. So there is nobody outside. All the people that were being interviewed, that were being surveyed, play all the three games. Play any of the three games, sorry. They play any of the three games. So that is going to illustrate that. So what it means is that we can say, since they are interviewed, we can say that it's not in all cases, but for this particular case, since all the people that we have been interviewed play at least one of the games, it implies that the universal set is equals to T union F union V. This is what this statement implies. So there are all the people that were interviewed. So you need to have that at the back of your mind also. So there's no all of them play at least one of the games. So now we can now start solving this problem. You can add all the numbers you have given, add them together. Everything must be equals to 90. So let's do that. So we have 2n plus 10 minus n plus 2n. Okay, let me do it like this first, so it will be simpler. 2n plus 2n plus 2n. Now we have plus n, then 10 minus n, 29 minus n, then 19 minus n. Everything must be equals to 90. So if we add this together, let me put up my calculator. So now we have 10, that's 39. 39 plus 19, that's 58. So I'm coming. So this is 58. This 6n, that's 7. 7 minus 3, that's 4n. 4n is equals to 90. So 4n is equals to 90 minus 5, 8. So 4n is equals to 32. Our n is equals to 8. So we've gotten the value for our n. Now, our n, all those who are playing all the three games, is given as n. They play all the three games, that's n. So we can say invariably. So let me write that out. Copy this and paste. That's 8. Now, since you have gotten that, the next thing is to find all those who are playing football all together. Those who are playing football all together. Those who play football all together, that means NF. So we go to the circle of football. So from this thing, we can see that 10 minus n in brackets plus 2n plus n plus 19 minus n. That is those who are playing, all the people that are playing football all together. So let's add this. This is 10, 29. Then we have 2n. That n cancels that. So plus n. Plus n. So our NF, those who are playing football together, is equals to 29 plus 8. We have already found that n is equals to 8, so that's 37. So, we've been able to get the value of those who are playing football. That is 37. So let's put, say how many play football all together. So I need to write that out. So how many play football all together? That is NF is equals to 37.